DMoving. The CAD that moves continuously. Drawing activity requires the use of a pen and paper, or a CAD system. Whether you are using your computer or not, you should start with the so-called blank sheet, a space to be filled with something. Starting a project without a base requires commitment and resources. DMoving enables us to avoid starting from scratch, thereby always providing us with a pre-packaged drawing that helps us to overcome the initial hurdle. A design base that adapts flexibly to the various situations cannot simply be made up of static drawings. What we need is dynamic drawings, drawings that move according to pre-established rules. General concepts. What is DMoving? DMoving is a unique CAD application based on a newly developed graphic configurator for which the acronym DDM, Dynamic Drawing Manager, has been coined. The name DDM indicates that the solution as a whole handles a series of dynamic drawings that we'll call DD. The DD, dynamic drawing, object consists of a set of ST, static drawing, which are comparable to conventional CAD drawings. The SD are placed within a sequence as if they were the frames of a cartoon but follow a logical functional sequence and not time as is the case with cartoons. In addition, several sequences can be linked to manage more complex variations. Dynamic drawings are organized into libraries, and DD can be placed side by side to create multi-drawing configurations. From here on, we will call the configuration CONF and the configuration sets of the DMoving libraries configuration set. Each library contains a number of configuration set. DMoving organizes reuse. There are design areas that benefit from considerable financial resources. If the designed object is produced in large quantities, an appropriate economic return can be obtained and invested in the following projects. If this condition is not met, such as in the design of civil works, the time and cost of design is crucial. To overcome this problem, design studios use existing processes to modify them and derive new ones. Reuse is especially important for small works, but care must be taken. Reuse requires the creation of its own well-organized library. The internet can be a good resource for populating your library, but it has problems. You can find interesting collections of drawings, both free and paid, but these are almost always fragmentary and obviously not conform to a single standard of archiving. You also have to face a vast world that offers a lot of irrelevant or low-quality content, all aggravated by advertising and viruses. The operator tends to take a long time and is consequently diverted from the project. What are the DMoving tools designed to organize reuse? 1. Large quantities of dynamic drawings that can be modified according to pre-established rules. 2. Internal search engine to find the drawings you need at the right time. 3. Integration with CAD that the designer normally uses. Big masses of data or highly verticalized algorithms. The highly verticalized CAD programs offer functions for the semi-automatic generation of various elements such as ladders, walls, electrical circuits, mechanical components, metal structures, etc. The example in the figure shows a model of a building with masonry generated by a specific application. Strong vertical applications attempt to replace the human mind and somehow provide design elements calculated from specially written algorithms. This approach allows for the achievement of important targets, but it's very expensive and has inherent limitations. To understand these limits, we can refer to what has happened in recent years with big data and AI. Artificial intelligence. The case of Google Translate is emblematic. Statistical analysis beats the algorithms for language translation. Initially, much of the software written to perform machine translation included the definition of grammars and dictionaries of different languages, a difficult and costly process. Google, under the guidance of engineer Franz Ock, has replaced this with a purely statistical approach. Mass data analysis, for example the English and French translations of various public domain texts, has produced better translations than the old AI. Algorithm-based method. The larger the mass of data, the better the result. DMoving bases its response on a large mass of drawings, thanks to the optimization of the storage of graphic data. A file containing data for SD is much smaller than traditional CAD formats, e.g. DWG, DXF, or document formats such as PDF. The SD is not simply a drawing that is autonomous and isolated from the context, but is a gear that is part of a mechanism. Some information can be stored in this mechanism only once without being redundant in all drawings. When exporting drawings to a common CAD program, this generic information is entered in the interchange file, which allows you to brilliantly manage very large sets of drawings. The dynamic drawing offer is not only potentially very extensive, but also easily expandable. Just add the missing SD to the DD you want to expand. Separation of duties. Let's imagine that we want to design software that draws metal staircases and that we are going to write an algorithm for this purpose. As already mentioned, we can achieve some very good results, but to achieve them we need to combine different disciplines. In this case we need at least a programmer and a staircase designer. They need to understand each other fully to share the same objectives. They will quickly find a common language and I leave the answer to you. DMoving allows you to keep your skills separate. Programmers provide a general purpose, environment, while designers can put a wide variety of contents into SD. The maintenance of the solution is also more linear. The eventual replacement of one of the actors would have an impact. DM grip. But how can we move along the paths that allow us to find the SD we are looking for? For this purpose we have a sort of grip that we will call DM grip. We must be careful not to get confused. Grip allow you to act on the remarkable points of entities and are typical of many CAD programs, including DMoving. The DM grip express the typicality of DMoving and have the function of finding a drawing or a set of drawings. In other words, the mouse action on DM grip causes DMoving to dynamically select the drawing that meets the geometric condition indicated by DM grip itself. The operator acting on DM grip has the feeling that he is acting on the drawing with a change command when in fact he is performing a query on the DMoving database. The following figure shows a DM grip tied to the side of a building. When this is dragged, the wall moves accordingly and the house is transformed according to the rules imposed by the author of the library. The production of DMoving libraries does not require the writing and maintenance of ad hoc code, but while the user acts on a DM grip he has the feeling that the drawings are governed by a specially written algorithm. The following figures show a simple example that can give a hint of reflection on the role of DM grip. Can a generic stretch command add the bricks that are needed to raise the chimney? Of course not. With a traditional CAD you have get a hold of the drawing and arrange each line. The author of the library also acted on the width of the chimney to increase its stability when it is higher. DMoving doesn't have the third dimension, but does it still make sense to use a purely 2D CAD? Three-dimensional representation methods allow the immediate visualization of the object in its shape but are not to be confused with 3D modeling, which is a CAD design tool. The two-dimensional drawing is a product documentation tool and is therefore a means of communication of concepts and technical information. This information is available to anyone with a minimum technical drawing basis, such as the operator who must build the product or the purchasing department who must order raw materials and components. Three-dimensional modeling is an excellent working tool but is difficult to transform into a vehicle for technical information. This is demonstrated by the fact that there are no unanimously recognized treaties on the indication of dimensions, sections, and other requirements to be indicated on the 3D model, whereas they have always existed for two-dimensional drawings. See for example ISO or ANSI standards for technical drawings. Many CAD 2D operators have a misplaced sense of inferiority to those who use advanced technologies and work in 3 dimensions. In reality, when you have to choose whether to work in 2 or 3 dimensions, you simply have to take into account the final use of the graphic. If you are producing a 3D model that cannot serve as a master for the entire process, ask yourself a few questions. 3D master methodologies make the use of 3D modeling strongly convenient, but every step that declassifies the process to 2D master is an element of disvalue of the process. The pure 3D master condition consists in using the 3D model as the only container of all the information necessary for the realization of a manufactured product. Suppose you design and manufacture an automotive component in a highly advanced environment, where even the skilled workers, who physically make the part, consult the 3D model from a dedicated terminal. The 3D master process does not prevent the generation of 2D processes, but these must not contain additional information not present on the 3D model. In other words, 3D master is considered safe when it is not necessary to go through the consultation of a 2D elaboration to construct the artifact. Any annotation on the drawing, a text indicating, for example, that hole 2 was drilled before hole 1, not present on the model, would downgrade the 2D master process. The 2D master methodology is also used in high-tech fields such as aeronautical design, as the pure 3D master process is difficult to sustain, both for production and certification. In conclusion, we can say that the absence of 2D CAD is often utopian and counterproductive, while 3D modeling is useful but not always necessary. Axonometric views. Axonometric views can be very effective in representing an object, but if we look at the examples in the figure we can easily imagine that, starting from an axonometry to obtain such an object can be very expensive. To this end, the DMoving libraries contain various axonometries that, under the action of DMGrip, automatically modify themselves in a way that matches the flat views.